Every second, millions of data packets zip through the internet, carrying our emails, videos, and messages to their destinations. But have you ever wondered how they get there? It's a mind-boggling journey that spans the globe. The internet's backbone is made up of massive networks called autonomous systems, which are controlled by internet service providers like AT&T and Verizon. These systems are connected by high-speed fiber optic cables, some of which can transmit data at speeds of up to 100 gigabits per second. For example, the Maria submarine cable, which spans over 4,000 miles, can handle a whopping 160 terabits of data per second. This is equivalent to streaming over 40 million high-definition videos at the same time. Other notable examples include the Asia-America Gateway and the Japan-US Cable Network, which have capacities of 20 and 80 terabits per second respectively. There are over 60,000 autonomous systems in operation today, with major players like Google and Amazon also operating their own networks. The internet's backbone is a complex and vital infrastructure that enables global communication and data exchange, with thousands of networks and cables working together to transmit vast amounts of data every second. Chapter Routing Tables, about how internet routing works behind the scenes. When you send data online, it's broken down into tiny packets, each with a unique address, consisting of a 32-bit or 128-bit string of numbers that identifies the sender and receiver. These packets are then routed through the internet using complex tables that map out the best path to their destination, taking into account factors such as latency, traffic, and network congestion. The Border Gateway Protocol, or BGP, is the system that manages these routing tables, and it's used by over 60,000 networks worldwide, including major internet service providers like AT&T, Verizon, and Google. In fact, the global BGP table has grown to over 750,000 routes, making it a daunting task to manage, with some networks having to update their tables hundreds of times per second to ensure efficient data transmission. For example, companies like Cisco and Juniper Networks provide specialized equipment and software to help manage BGP routing tables, highlighting the complexity and importance of this process in keeping the internet running smoothly. Packet switching is the technology that allows data packets to be transmitted efficiently across the internet. It works by breaking down data into small packets, typically around 1,000 bytes in size, and transmitting them independently, allowing multiple packets to share the same connection. This technology was first developed in the 1960s by the U.S. Department of Defense's Advanced Research Projects Agency, or ARPA, as part of a project to create a robust and fault-tolerant network, which eventually became the foundation of the internet. Over 50 years later, packet switching remains the core technology that enables the internet to function, with billions of packets being transmitted every second. Companies like Cisco and Juniper Networks have built multi-billion-dollar businesses around packet switching technology, with Cisco alone generating over $40 billion in revenue in 2020. The widespread adoption of packet switching has enabled the creation of online services like Netflix, which relies on packet switching to stream over 100 million hours of content every day. Chapter Network Congestion, about how internet routing works behind the scenes. As more and more devices connect to the internet, network congestion becomes a major issue, with over 22 billion devices currently online, and this number expected to reach 38 billion by 2025. When too many packets try to travel through the same route, it can cause bottlenecks and slow down data transmission, resulting in frustrating delays for users. To alleviate this problem, internet service providers use techniques like traffic shaping and congestion control, which can reduce network congestion by up to 30%. For instance, the TCP/IP protocol has built-in mechanisms to detect congestion and adjust the transmission rate accordingly, with algorithms like slow start and congestion avoidance helping to prevent network overload. However, with the rise of streaming services like Netflix, which accounts for over 15% of global internet traffic, and YouTube, Network congestion is becoming an increasingly pressing issue, with the average user experiencing buffering or delays at least once a week. The future of internet routing is all about speed and efficiency, as the rapid growth of online services and devices puts increasing pressure on networks to deliver fast and reliable connectivity. New technologies like software-defined networking, or SDN, and network functions virtualization, or NFV, are being developed to make networks more agile and responsive to changing demands. Companies like Google and Facebook are also investing heavily in new undersea cables and data centers to support the growing demand for online services, with Google's latest undersea cable project, Duna, expected to increase transatlantic internet capacity by 250%. In fact, the global internet infrastructure market is expected to reach over $100 billion by 2025, with the routing equipment market alone projected to reach over $15 billion, driven by increasing demand from countries like China and India, where internet penetration is growing rapidly. With over 500 million new internet users expected to come online in the next 5 years. Thanks for joining us on this journey into the world of internet routing. If you want to learn more about the technology that powers our online lives, be sure to subscribe to our channel and check out our next video on the fascinating world of cybersecurity. Don't miss out on the opportunity to uncover the secrets of the digital world.